All right, okay, so what we're going to look at here is a general form of linear equation. So what we just got to recognize is there's a connection between the numbers that make up the rule for a linear relationship, and for example, those found in a table. So that's this point here, and the numbers that we can get from a graph, such as a gradient and the y-coordinate when x equals 0. So what we've referred to as the y-intercept. Okay, and so from that, okay, once we've got that gradient of y-intercept, we can actually write our rule. We don't need a table to do that, and we don't need any further analysis. We can get information, and the rule we're using is something you've, in a way, you've seen before, just not shown like this. And when we say it's a general form, it's because that m corresponds to the gradient, which we know how to do. We've shown it, but let's write it again. That's the rise over the run. And we've got this part here, and that is the y, what we call the y-intercept. Okay, and so that's what general form is, and we can get that from our equations that we've seen, but also we can get that from the graph. So let's look at, if we've been given an equation, we can use our knowledge of this general form to know what the gradient is and the y-intercept for each of these equations. All right, so let's quickly go through that now. So this position, this pronumeral here next to the x is what our gradient is. So for example, here our gradient would be 5. So let's write, I'm just going to say something, gradient equals 5. This one here, my gradient is, it's the pronumeral in front of the x, where that would be. So that's going to be, my gradient is going to be equal to 2 over 3. And on this one here, it's what's in front of that x there. And I have a gradient of equal to -3. So that's what my gradient for each of these. All I have to do is look at the equation, and that's what I get my equation, my gradient as. Now, if I then pick this part, remember that's my y-intercept. So that corresponds to that. So y-intercept equals -3. The y-intercept here is +5. So y-intercept equals 5. And down here, it's going to be there. So the y-intercept here is equal to 1. So that's how we can use our equations to work out what our gradient and what our y-intercepts are. Now, that was with the equation being given. Now, I can actually get the same information from the graph. Remember, from this graph here, I can actually work out what the gradient is and what the y-intercept is. So let's write this equation out. I'm going to write y equals, it's going to have an x there, and there's something that's going to go here and something that's going to go here. So this is going to be the y-intercept, and this is here is going to be the gradient. Oops. Okay. And that's what we're going to put in there. So let's actually quickly do that now. So let's look at the gradient. So my gradient, I'm actually going to pick this point here and this point here. All right. So I've sort of picked 2 points where I can easily read off stuff. My remember, that's my run, and that's equal to a value of 1 because I've gone from 0 across to 1. Let me show that. 0 from here, from 0 across to 1. And then I go up to here, I'm going up 2. So my rise is equal to 2. So if I remember, rise over run is my gradient. So I'm going to have 2 divided by 1. So my gradient is going to be 2. All right, so that gives us our gradient. Now I want my y-intercept. So y-intercept is when x equals 0. Okay, so x equals 0 here, it's anywhere along there. It's where x equals 0. But what we have y-intercept is where this line cuts through that spot. And it cuts through there at -1. So what we're going to have is a rule that says y equals 2x minus 1 for this graph. Now, let's look when we've got another example. Now, remember, y equals something x. I'm going to have a space there, something and a space there to go for it. So let's have a look. So my gradient is these 2 points here. So I'm going to go, so my run is 2, and my rise is what we call 1, or -1 in this case. The reason I say -1 is because it's a value of 1 there, but in terms of if I go rise over run, the rise is -1 because you're becoming more negative there. So that's the way to think of it, to keep that in mind. And my run is 2, so my gradient is going to be -0.5. So now, where does it cut through? Remember, here it cuts through at -1, so therefore my y-intercept is -1. Okay, so in this example here, what we've got is a horizontal line and a vertical line. And what we really look at for a horizontal line, where we want to find horizontal, where does it basically cut the y-axis? Okay, so basically in this case, y will equal, it cuts it at there, it cuts it at 2. So in that case, it's a horizontal one. Where does it pass through y-axis? Okay, and the answer would be y equals 2. For this one, okay, for a vertical, let me pick a different color here. Vertical, where it pass through x-axis. Oops. And we can see that that happens at 1. So in this case, our value would be x equals 1. And then, for example, if it was there, it would be x equals 2. If it went here, you'd have y equals -2, etc., etc., etc. Okay, so that's how you calculate and work through these ones.